Right, so in this session we're going to talk about the data representation and modeling. Starting with introducing myself, my name is Khalid Ismail, and before joining Birmingham City University, or BCU, as a lecturer in computer science, I did have my PhD in computer vision from University of Leeds in UK. That's back in 2013, around 2013, and then after that I've worked on various research positions in various universities, starting with research fellow as a research fellow in University of Leeds after having my PhD, postdoctoral research assistant in University of Bath, and been working as academic in University in Egypt as well. Then I've been working research fellow University of Nottingham and a senior research associate at Durham University, and then lecturer or assistant professor in Birmingham City University in the Department of Computing and Digital Technology. I'm also the course director for Computer and Data Science course. It's an undergraduate course, and also the Computer Science with Artificial Intelligence. So basically, both of them are similar courses. We're trying to finish the Computer and Data Science course and replace it with Computer Science with Artificial Intelligence. It's just both of them are closer to each other, but we're just changing, you can say, like branding the course with the small modifications or few modifications to get up to date with the technology in AI and machine learning. My research interests is in computer vision, mainly in computer vision. More specifically in deep learning and machine learning. So you're probably gonna notice that at the last session that I'm mainly interested in images. I like to work with images, videos, and so on. So I implement deep neural network machine learning in the data that I'm using mainly is image data. So you can basically use machine learning techniques or deep learning techniques. So you're going to learn about it during the course in different data. So your data can be text data, the same as you going through during Hackathon, for example, which is a text sort of data. You can work with images, you can work with sounds. So you can work with many type of data or implementing machine learning techniques in many types of data. So I am working as a personal, my main interest is in the computer vision, which is image type of data. Been working on autonomous driving and autonomous driving or self-driving cars with few collaboration with Jaguar Land Rover, Renault in that research activities, and also X-ray imaging. I'm going to talk about that in details in the last sessions. So basically, we implement AI into X-ray machines and also AI in medical application. This is a few recent projects that I've been doing. For example, this is we're trying to build here self-driving cars to help us with the research activities for for autonomous vehicles. This is one of the results. What we have done is basically about localization. You can see here, this is a kind of scene understanding as part of autonomous or self-driving cars activities. As you can see here, we can basically able to detect the cars. This is a car, this is another car. We can detect even the colors of the cars. We can detect other elements on the roads. It's about 40 object class that we was able to detect. We've been using AI and machine learning as well to do their route structure. That was in Nottingham, so I was quite interested on segmenting the root structure and able to identify the root elements. And you can see you can do that through AI and machine learning. Other related activity, for example, X-ray images. So you can see here, this is a bag, the similar bag that you took to the airport and you bought it in the X-ray machine. So you can see here that, again, using AI machine learning to simply detect any threat items within the bag, and that might give alarm to the X-ray operators. Okay, so I hope that's quite, like a quick introduction about myself and my research element, which lies mainly in AI and machine learning related to computer vision and image data. Right. So let's thinking more deeply about data and computation in this session. So before we jump deeper into that, I'm not expecting you to, during the next couple of sessions, this session, next couple of sessions, to understand everything. We're trying to make like a kind of overview, giving you a little bit more of understanding, more of a bit of idea. All of these things you're going to go through it deeper during your degree, your MSCI degree. We're not going to jump. We're not going to jump into deeper mathematical equations, some kind of things. It's not required for you actually to have a large amount of knowledge or to be experienced in mathematics, for example, to join this course. But yeah, we're going to have an overview about for example, data modeling and classification using machine learning classifications. Right. So we have seen, I believe you have seen this morning, things such as semi-structured HTML and unstructured text, and these structured and semi-structured or unstructured has been represented using tables. And these tables has been used for visualization and for learning, right? And then within these tables, you can simply do some manipulation to these tabular data. Manipulations such as, for example, projection, i.e. subsetting in fields, selection, so you can simply select a sample from your data, or some observation from your data. If you can think about, you have the table here, your tabular data. So you have columns, which we call it fields, or sometimes we call it features within the table. And then you have the rows, which is the observations of samples. Each observation is a sample. Okay. If you think about, like, if you have a table of patients, for example, and you need some, for example, some data for that patient. So you can think about, like, every row you have is observation which related to a patient, and for the fields or for the columns that you've got, simply some attributes or properties or features. For example, heart rate. What is the heart rate count? What is any other medical fields or medical data that related to that patient, right? And then you can simply apply, basically compute some sort of function over each row, column, or cell. Then you can simply link tabular data, i.e. you can merge or join data altogether, right? So now this is a kind of simple, we can think about like a simple processing on the tabular data that you can do. If you have tables, data on tables, so you can simply apply this kind of processing over the tabular data. Right. Now we're talking about the design, and this word design, we're going to simply going to learn more what we mean by the design. Designing is important even for the data itself, and it's quite important. You can think about like a task in terms of you design everything. Like if someone would like to make a software, for example, I think some of you not have a software background, but if someone would like to make a software for you're working in a software company and another company came or client came to you to make a software. So the first things that you basically need to do the design, okay? And a part of this design is basically designing your data, right? How we able to encode our data and what are the implications of this encoding for the data. Right. So first question, what we are trying to capture from the data we have. Okay. So simply the structured data should capture the semantics of the data. And what do we mean by data semantics? This topic has basically the topic of the meaning of data semantics has been preoccupied philosophers since at least Plato and Aristotle, and basically computer scientists for most of the lifetime on the field, trying to do, trying to, give a kind of meaning of that. So you should not worry about that too much. What is about the data semantics? But normally, what I would like you to understand here is that the data semantics mainly mainly referring to the interpretation of data within some context, right? So this includes the understanding of the relationships of the data, the attributes of the data, and also the values that the data represents. So that's what we call it, data semantics, right? Okay, starting with part of our goal here is to modeling concepts and instances, right? And we're going to, learn now what we mean by concepts and instances. The famous example for logic, or from logic and philosophy, attributed to Aristotle here, that all men are mortal, and Socrates is a man, therefore simply Socrates is mortal. Okay, so you can think about this, the logic and the philosophy behind the concept and instance. So you can think about that if you have all men is part of mortal concepts or class, sometimes we call it class. And if Socrates is part of a man or the main class, so simply Socrates is a part of mortal or is mortal. Okay, so the premise here, basically, we have concepts which are classes of things and instances of these concepts. The properties of the concepts, the main classes or the concepts, should appear in the instances. Okay, and instances can be related to other instances. Okay, so basically, data design is about trying to codify, we call it codify the above. Is that clear? We're going to go deeper in understanding for that, but is that clear, the concept here? So basically we have a concept or class called mortal. Mortal here is our concept or class, and we have men is basically part of, or simply you can think about it as a subclass or a subclass from mortal, and Socrates is an instance from the main subclass. So simply Socrates is a mortal or considered to be immortal. Okay, so that's simply the famous example, or this is the logic of modeling the concept and the instances. Right. So starting with some point here. Exactly, that's for the class inherits exactly that what we're going to see at the moment. So basically, the subclass that inherit the main class, it does inherit the properties of the main class as well. Okay. So okay, so we model knowledge using notations. This is basically dating back to ancient Greece. So we have classes or concepts or sets of entities. Okay, so you can think about it. These are the names of this, you know, these names. Sometimes we call it concepts. Sometimes we call it classes, such as in programming, for example, and we call it classes. And also machine learning, we mainly use that word, classes. Or sometimes you can think about it like a set of entities. You refer to databases, for example. Okay, and for example, this is a people. Okay, so that's the class we have, which is a people in this case. And then we have instances of these or of those classes. For example, Socrates, Aristotle, and then Plato. So these three philosophers are an instance of the people. Okay, and you can think about it in the wider version, right? So this is in terms of, for example, class people, and these are the instance of this class. So you can think about it like, for example, you have a class called animals, and within that class, there is subclass, maybe dogs, and another subclass called cats, and another subclass for another animals, and so on, right? And from the dog class, you know, like there is an instance of that dog, for example, as you know, subtype of the dog, for example, a Doberman or whatever the type of dogs, and the class of cats. Again, it's a name of cats, and so on, right? The same concepts you can think about it in cars, for example. We have a class called cars, and there is a subclass of the cars, simply maybe BMW, and then Toyota, and so on. So, and every one of these has instances, right? And the main, as we can see here, as Alistair has mentioned, there is something called inheritance. Inheritance means there is some properties in the main class, okay, the superclass. For example, the class animals, there is some entities or some properties such as taste, for example, smell, things such as these properties. And we have from the main class, which is animal, we have the subclass, for example, the dogs. So the dogs, you can think about it, it does inherit these properties such as smell, taste, and so on. There's another class called cats, which is again inherits the class called animals, and it does inherit the properties that exist in the main class, which is the animal class, such as taste, smell, and so on. Okay, so if you can think about this kind of concept in everything around you, that's basically you can model the data that way. Okay, we are talking here in this example about people and certain peoples, but you can model the problem that you have got in whatever you would like. Okay, model the data that you have, whatever the data in your own way, right? This data can be textual data, like text, like here, or can be actually other type of data, like images, for example. Okay, I'll give you an example. We do have, for example, self-driving cars. I'm talking problem that have been going through it. Self-driving cars, so you have working with images. So these images, maybe there is a class called people. There's some people you can see on the street. There is a class called zebra crossing. There is a class called roundabout. There is a class called building, and so on. Okay, and from the class called people, there might be a female or male, for example, if this is another subclass. And for each class, they have their own features and their own attributes. Okay, so I hope that's able, like it's you're able to visualize that in that way. Okay, so there are 3 different ways to looking at these. Okay, so these 3 ways we're going to like basically visualize or represent or model the data in 3 different ways. Okay, the first way is using the logic, and in this we call it knowledge representation. Okay, so this is the first way. We're going to talk about this way in a bit more detail at the moment. The second way is called knowledge graphs. Basically, within here, we're going to name the relationships between classes, subclasses, and instances. Okay, and the last, the third way to look into that is basically, we call it entity relationship modeling, or ER modeling. Okay, and this is simply a special case of knowledge graph. Okay, these 3 different ways basically can all be used to inform our design for the data frames or any hierarchical data. I guess we introduced data frames in the first session this morning, which is basically the table of data. We call it sometimes table data frames, or hierarchical type of data. Okay. Anyone has any questions so far before we move into these 3 different ways? Okay, looks good. All right, so the first way, which is basically modeling classes, instances, properties using logical predictions. So we can use something called logical assertions to simply describe everything. For example, classes, we have named categorized collections of items. For example, here we call all people are mortal. So the person here is mortal. You can think about it, or you can represent the logically by this expression. And classes itself has more specializations or subclasses. For example, men's are or men are people. So you can think about it or write it as expression that subclass of man and person. So the man is simply a subclass of person, or a man is person. Okay, and here we have a person is mortal. Okay, and we have instances. So we have here the class, we call it mortal, and we have another subclass, we call it person. This is the subclass, and the person is simply a subclass from mortal. And we have a man, simply a man is subclass from the person. And we have instances. For example, the man, we have a person called Aristotle, and this is simply an instance from the man class, or the man subclass in this case. Okay. In this case, we can simply do an infer prediction from class to subclass, or from that class to instance, using the following rules, we call rules. Okay, so if we have here X is a mortal and Y is a subclass from X, so simply we can that leads to the Y is mortal. Okay, so simply if the X is mortal and Y, we have Y is a subclass from X, so simply we can get the information that Y is a mortal. Simply here, if X is a mortal and we have instance in this case, if Y is instance from X, such as a person here is instance from man, is a person from man, so you can that leads to Y is a mortal as well. Okay, so this is, if you get simple as an example, so if we have a mortal here, or person is a mortal, and a man is a subclass from person, so simply the man here is a subclass from the man here is a mortal. Okay, if a man is a mortal and we have the instance here, Aristotle here is a man, so we can that leads us, or that's, you know, we can you know, like we can know that Aristotle is basically a mortal. Okay, so this way of representation, we call it logical predicates or logical assertions. Okay, anyone has any question from the first representation? So again, if we return here, so we start, we mentioned that we have the first one, which is a logic, and then which is a knowledge representation. The second way is the knowledge graph. So let's go to the knowledge graph. So knowledge graph is mainly a think of how people think about database tables and alike. Okay, so you can see here the arrow here, and in this case the head of the arrow, it does have a very important representation here. So the head of arrow means basically the person here is a subclass from the mortal. Okay, if we have the so mainly the head of the arrow in this case heading towards the subclass or to the instance. Okay, and you can see here the man. You can understand here the man is simply a subclass from the person. Okay, so if the man is subclass from the person, so simply it is, you know, inherit the properties or the attributes from both the person class and the mortal class. Okay, and you can notice here the man subclass is also a subclass from another class called adult, which is in turn, this class is a subclass from another class called life stage. So this class life stage has a different life stage, for example, toddler, baby, teenage, or and adults, for example. So the adult is a class which is a subclass from the life stage, and you can see a man here is a subclass from this. Okay. So in this situation, the man class or the man subclass, it does inherit the properties or the attributes of the adult class and also the attributes of the person class. And as a result of a person here in a subclass from mortal, so man as well inherits the attributes of the mortal class. Okay, and from the man class you can have instance, for example, Aristotle as an instant, and Plato as an instant, and Socrates as an instant. Okay, and we can represent using this knowledge graph representation the relationship between the instants. Okay, so Aristotle basically has teacher Plato, and Plato has teacher Socrates. Means in that case means Socrates is the teacher of Plato and the Plato is the teacher of Aristotle. Okay, so this kind of representation has teacher here is simply shows or represent the relationships between the instance that we have got. Okay, so here has a teacher. It can be anything else, can be a relationship. For example, if we have two instances, maybe married or any kind of, or student, maybe this is a student of that. So this is kind of, we call it like a relationship between the instances. Okay, and this is the second way of representing the classes and the instances, and the relationship between the classes and instances, and the relationship between the instances itself. Okay, anyone has any question for that? Anyone has a question? Okay. Right. So here, in this case, to determine if Aristotle is mortal, we simply follow link in the graph. For example, instance of or class of, to see if we can find a mortal. If we can simply decide if this is if the mortal or not. Okay. Google and many other services simply use the graph or knowledge graph that we can see here, such as Freebase and Wikipedia. So this also another common way to make that representation. Okay, so this is, again, let me return back to the three things. So we have covered here the logic, and we know about the knowledge graphs, and then we're gonna look at the entity relationship modeling. What do you mean by database are constructed? Alistair, so simply we have, what we're trying to do here is basically, you can think about this way is to construct the database. Okay, so we're using this way, this data representation to construct the database. And this is actually a good question in terms of here, because entity relationship graphs is one of the models and one of the common models to design, we call it design the database. Okay, you design your audit or your own database. Okay, for example, I'm teaching mobile module, mobile and application modules in the level 6 or final year. The students required 2 stages. First, they make design for a mobile application, and they need to use a database for that mobile application, and then they do the implementation. Okay, as part of the design of their database, they actually need to use, or they can use something like anti-relationship graphs, simply to design their database and also design their relationships between the database. Okay. So ER, entity relationship graphs, or sometimes we call it ER graphs, or sometimes we will hear this one, we call it sometimes ER diagrams. So this simply this rectangle sets here, you can think about it as classes. Okay, so the person, the adult, the man, the life stage. This simply we call it classes, or sometimes we call it entity sets. So this is entity sets, and the properties normally shows as ovals, like this one here. So you can think about here that the person, we just mentioned that the head of the arrow here mentioned that or shows the direction of the inheritance or the subclass. So you can think about the man here is a subclass from adult, and the adult subclass from life stage, and a person here is subclass from a man. And you can see here that we do have properties here, or sometimes we call it attributes, which is, for example, in this case, name, ID, birth, and death. Okay. So the man class, you can see here, which is, we call it is an entity set. So you can think about the man because it inherits the person class. So it does inherit the attributes of the person class. Actually, this one should be here because that's the inheritance. So the man here inherits the person class, so it does inherit the death, the birth, the ID, and the name properties. So you can see here the ID, the name, the birth, and death. Okay. And for each record here, so you can see here each record or each instance or each row represent a person, in this case Aristotle and Plato and Socrates. Okay. So there is another way of representing the ER graphs, is simply by using a symbol for the relationship itself. Okay, so in this case we have the has teacher here as a separate links which represent some sort of relationships. Okay, so again we can see here the is a kind of relationship. So man here is a person, and man here is an adult, means the man here is a subclass from the person, and the man subclass here is a subclass from the adult, and the adult is subclass from the life stage. Okay, and the person here, it does have attributes such as ID, person ID, and the person name, which is simply an attribute. And we have another relationship here between the man and the person, is has a teacher, and we're going to simply means that some man here has a teacher from another person in this case. Okay, so it's very important for us to know that the subclass inherits all subclass, such as a man in this case, inherits all properties of the superclass. So it does inherit all of the properties such as name, ID, and others from the person class, which is superclass in this case. Okay. The superclass also include all members of the subclass. For example, if we have a man here, we have 3 persons in the man. So simply the superclass person, it does include all the members of their superclass. Okay, if we can think about the animals, so the animal as a superclass, it does include all of the animals that we have got, the dogs, cats, and all of that, and all of the instance or the member of the class is simply included into the animal superclass. Okay. Yes, Restor, this is exactly very similar to how the database is constructed. Actually, one of the main construction of database we use is the ER diagram or interrelationship diagram. Okay. Before we going on, does anyone has any question? So we do have here another attributes such as birth and death. Any question? Anyone has any question? Right. So let's talk about entities and relationships in corresponding to relationships and data frames. So in this process, like the planning phase of the project, exactly. So this is one of the project is the planning or the design phase of your project. So normally, if you're working some certain project and you need to design the data for that project. Say, for example, if you do a library, software for a library, for example. So you need to have design the database of this library. The design of this database might be, for example, you will have a class called books, and there's another class called authors, and there's a relationship between books and authors, and maybe you have another class called publisher, and there is a relationship between the books and the publisher. So you think about it this way. So you basically make a design for your database, the database that you're going to use for your project. So one of the ways that you can use to make the design for your database is to use ER diagram. Okay. Are the shapes and colors you use each element significant industry standard? So no, it's not significant on a industry. So we're just using here, but not the colors, but the shapes might be standard. It depends on what you're using. So the shapes sometimes, or most of the time, it depends. So you can use the ER diagram in, for example, UML diagrams or so on. So the shapes does have a standard, but the colors is not standard in this case. Okay. So for example, here the rectangle here, it does represent the entity set, and the diamond here represent the relationship. Okay. And the circle mainly represent the attributes. Right. So moving here, so we do have the entity set. So simply we mentioned the entity set or the class, which represent all the entities of a type and their properties, such as person here, which has ID, name, birth, death properties. And we have man here, which basically inherit exactly the same field, and possibly can be added its own, okay, which is not shown in here. So, for example, if we have these 4 properties, the man here has his own properties, okay, and these properties basically this is actually specialized to the man here in this case, okay. The relationship set is simply, for example, has a teacher and represented by this graph here. Okay. Let's see the person, also a man table. This looks like that, which has these 3 or 4 attributes or properties: ID, name, birth, and death. Okay. And the way we simply represent the relationship in the entities and relationship diagrams is by simply having it as a table. So in this table here, or data frame here, we call it has a teacher, which basically link the teacher and the students. And you can see here that the teacher is 1233, which is the ID of Socrates, sorry, the ID of Plato, and the students is 1234, which is Aristotle, right? And the same thing here, the 1232, which is the ID for Socrates, which is a teacher, and Plato. So from here, from this table here, I can understand that Socrates is the teacher of Plato, and Plato is the teacher of Aristotle. Okay. Is that clear? Anyone has any questions? Right. So the table simply, the tables let us include a graph within the data. So you can think about from these two tables here, from the person table, which is a set of entity table, and the has teacher table. So you can think about here, we can draw a graph that represent the data encoding here, which is the Socrates here has a student, which is Plato, and Plato has a student, which is Aristotle. And if you go the other way around, the Aristotle has a teacher, and this teacher is Plato, and Plato has a teacher, and this teacher is Socrates. Okay, any questions so far? Okay, so you can simply make this model or using the ER diagram or ER model to simply able to define tables and data models for a complicated problem or complicated model, such as this one here. So you can think about it here. You can see you have a class or a set of entities called molecule. The molecule has a property, ID, and sequence. You can see here the small molecule has is actually a subset of the original molecule, and you can see the protein as well has a domain and ortholog, and the protein is a molecule in this case. So this kind of, you can think about here, so you can understand from this graph that these are the attributes or the properties of the entity. And we have a few entities here, and this is the relationship between the entities. The relationship can be is a, which is simply a class. This is the subclass and the superclass of it, or has a, which is simply represent another relationship as well. Okay, so this diagram here shows that ER diagram simply can represent a more sophisticated data models. Okay. Anyone has any questions so far? All good? Right. So from the basics of ER diagrams or the entity relationship diagram to general database design, so we use that to make a database design. So simply we deciding the entities, the relationships, and the constraint is part of the database design. the decision of how many entities or what entities that we have got, the relationships, and also the constraint is part of the database design we've got. There are ways to do this to minimize the error of the database and make it easier to keep consistent. We're going to have a break. We just after this session, maybe in 5 to 10 minutes. Okay. For this class, we simply we're gonna simply consider a simple ER diagram. Okay. There is some common point of confusion. So relational data can only capture flat relationship. That's not actually true. So the tables simply represents the relational data can represent graphs as well, which can be traversed by queries. Okay, so you can think about it this way. So this is the tables here, and you can see that the table here, the two table here, I can simply represent the data, the tabular data or the data here into a graph. Okay. There is hierarchy versus relations, which is sometimes we use something called NoSQL versus SQL. NoSQL stands for not only SQL versus the normal SQL or standard query language. Sometimes it's convenient to take data we could modify as a graph. For example, a person owns cell phones. So instead of having the data like this way, such as entity relationship, we can save it as a tree or a forest. Okay, so for example, the first branch here that we can use. So there's a person called Jai, which has simply two phones. The first phone is Apple, the second one is Samsung, which has different models here. And there's another person called Kai, and this person does have only one Apple phone. Okay. So the not only SQL data is simply you can use the data in this format, and this is simply we can store it in a JSON format. If you have heard about a JSON format, the JSON format is simply a kind of structured format, unstructured format such as this one, and simply used using NoSQL systems such as MongoDB or Google Big Tables to make to simply store nested objects or possibly some binary objects in this case. For example, here we do have this person here, Jai. It does have two phones in this case, and which is we call it a nested object. And the other person, there's another person which has only one phone. Okay, so nested objects. The nested objects can be captured in relationships via multiple tables. So, for example, in this case, if we're going to represent this data model in table, so you can think about it that we do have person name. The first name is Joy, for example, and the second person is Kai. And then, so for example, the ID here is 11, and then the ID here is 12, for example. And we have another table, it's called phone. And you can think about the first phone, for example, is Apple phone, and the second phone is S or Samsung, and there's another phone called Apple, another version of Apple, and this is different model. And you can think about linking these two phones with J by simply having the ID of the person here of J11 and this 12. Okay, so this is the way to represent the nested form, or the nested object can be captured in the relationships via multiple tables using this way. Okay, so a recap. This is the last slide. So basic concepts. The knowledge is typically represented as concepts or classes. Okay, so that's the knowledge that we have got. We can represent it as concepts and classes, which can be generally thought of as a corresponding to tables, i.e. each class or each concept can be represented as a table. Also a notion of subclass, which simply including inheritance fields. So the superclass, the properties in the superclass is inherited in the subclass. And we do have instances. This is the instance of the class, which is simply represented by the rows in the table. We have talked about the knowledge representations and the three ways of the knowledge representation, which is the logical way, or the graph way, and the ER or entity relationship way. And then we end up with looking at the not only SQL system, which simply support hierarchies such as nested hierarchy, and this can be represented in a sort of tree. One example, when we're doing the data, for example, for self-driving cars, we try to annotate the data or make annotation for the data. Annotation means we do see which classes that we've got in the images. Normally, we represent the annotation in a way that's represented in a tree way, or and not only SQL systems. Okay. Any questions so far? Anyone has any questions? All right. So that's I think that's the first session, and then we're going to have a 10 minutes break. I'll stop recording now. So we're going to have a 10 minutes break. So we're going to meet at 1:40. Yes, all the slides will be distributed. It's no problem. Okay. So thank you everyone, and meet you in 10 minutes for the next session. Thank you.